My project focuses on understanding how polymers can help in the clustering of different ionic structures and comparing how ionic structures form passively in water versus how these ionic structures form when polymers are introduced into the system, and how polymers can help mediate this clustering through the influence of positive and negative charges between the polymers and the ions. At my home institution, I worked on much more coarse-grained and larger scale systems for longer time periods, and here I'm learning much more on the atomistic approach and how things are done in very short time periods. That's a very new approach that I haven't taken before. Thus far, I've worked with a graduate student, Sheena Hilberg, and she has helped me understand how the particular software used in this laboratory can help model atoms and molecules on the atomistic scale.
Kirill has prepared a structure of the molecule that we want to make using software that you can see here. It's only in 2 dimensions, and we have this charged polymer that we want to make in our atomistic simulation. So we've been working through how to get those to be represented in something that's three-dimensional, three-dimensional in the computer, that we can use in our molecular dynamic simulations. The work that Kirill is doing here of looking at the ions aggregating in solution when the polymer is present is going to help in a broader project that we have in the Alexander Katz group, where we are looking at how polymers can in general change the aggregation of ions as they assemble into crystals, and they can assemble in specific orders that create different crystals for different structures. We're going to use this information that Kirill makes, and that data will be directly applicable to the next steps in the project. Specifically, crystals that are relevant for biomineralization, the formation of teeth or bones or shells, and this is relevant as well for pharmaceutical companies who do the crystallization of drugs so that they can form pills out of the drugs that they create, and a lot of different techniques that use organic molecules in the presence of ions to kinetically change what shape the crystals make.
So what we're doing here is we have polyacrylic acid, a negatively charged polymer, in a system with water and counterions to neutralize the charge of the system. Here we're letting the system relax into a steady state, where after which we will add additional calcium and carbonate ions, where we can then see how the polymer helps clustering of these calcium and carbonate ions into different crystalline structures. In this research experience, I gained the valuable opportunity to work with people outside of my home institution and learn new techniques and practices that I would previously not have known, and how these different techniques and practices can be applied to fields outside my own.